Hello everyone. So today we are here with the second chapter, which is the electricity. First chapter we already did, and there is a lecture on that. You can watch it out, and that is the ever-evolving world of science. We discussed it completely. Today we are here with another chapter, that is the electricity, circuit and their components. So we will try to understand. This is the basically in class 7. We give a basic of electricity chapter. This chapter is really vast. You will learn about this chapter again in class 8, then again in more detail in class 10th, then 12th. So this chapter is really vast. Okay, here in this chapter we'll be talking about the basics of electricity. We'll talk about the matter, we'll talk about the charges, we'll talk about the electric current, we'll do some questions. Okay, we'll talk about the daily life applications, different cells, batteries, these things we'll try to discuss. Okay, now before starting any chapter, the first thing that comes in mind, that why we are reading this chapter, so let's assume your life, at least now, okay, 21st century, now assume your life, at least one day of your life without electricity. Okay, it's horrible, right? Like, because there's a lot of things. I'm able to connect with you with this laptop, with the internet, okay, or if you are watching on the mobile phone, so everything is somewhere working because of the electricity. Okay, that's why reading this chapter, trying to understand how the things are working. Let's say if you are charging your phone, there is a cell, there is a battery inside it, how it is getting charged. Okay, if you're watching TV, how the TV is working, how the electricity making the TV work. If the fan is there, how that electricity making the fan move. So there's a lot of things. Basically, there's a lot of applications of electricity that you see in your daily life, but you never tried thinking about them in the more detail. So that what, not complete detail, but little bit kind of the basics of electricity that we will try to understand in this chapter. Okay, well, we will start with the understanding of the atoms and the electric charges. First we'll talk about the matter, then we'll talk about the charges, different type of charges, positive and negative charges. What are the properties associated with the charges? Okay, and its SI unit and everything we'll talk about. We'll talk about the electric current. We will define the electric current. We'll do some numericals on that. Some 2 3 numericals we'll try to do. And next we'll talk about the electric circuit. And then at the end we are having conductors and insulators. And that's not the end. There's some more in this chapter, so that we will try to understand in this whole chapter. Now, starting with the very first thing, that what are charges. Before charges, let us try to understand what are matters. So if I have to define the matter, so matter, as you know, anything which is having a mass and some occupy space, means I can say it is having some mass and has some volume, then we say that it is a matter. Coming to matter, matter is made up of atoms. Okay, all the matter are made up of atoms. Okay, inside the atom, if you try to see, so here it is the nucleus. Just not much of chemistry, I'm not going into much detail, but little bit of chemistry. Okay, so there is a nucleus and there are orbits around the nucleus in which electrons are there. अच्छा, बात करें इलेक्ट्रॉन्स की, so electrons are negatively charged. Okay, it has a negative charge on it. Okay, how much exactly? Achha, this is not of your scope. It is actually 1.6 into 10 to the power minus 19 coulomb. If you understand, that's fine. If not, then that's not, at least in this syllabus. You will learn about this in class 10th. Okay, that's not required as of now. So basically, let us remove everything. So basically, in an atom, there are nucleus in between. There are electrons which are revolving around the nucleus. Okay, let's say, for example, I'm taking any random atom. Let's say I take nitrogen. Okay, so nitrogen has basically 7 protons, okay, and 7 electrons. Fine. Let's say, just assume, I'm not going into much detail of chemistry. Let's say I take 1 electron outside. Now what happened? I'm having 7 proton and 6 electron. Now proton is having positive charge on it. Okay, proton is positively charged, electron is negatively charged. That you remember. Now proton, which is positive charge, it become more as compared to electron now. So this whole atom becomes negatively charged. Clear? Is that clear? Now let us remove everything. Now let us talk about how an atom or a matter gets the positive charge. From here you can get some idea. Let's say any atom, and I put another electron in this one. Achha, last one it become positively charged. No? So now I will talk about how a matter gets negatively charged. Let's say I put another extra electron in its orbit. So number of protons, okay, become less than number of electrons in this atom. So this overall, this atom become negatively charged. Negatively charged. Clear? Clear? So that's how. Now, as a whole, we can talk that any matter can be positively charged, it can be negatively charged. If there's no charge on any matter, then that charge is then that matter is called as a neutral. Okay, then that is a neutral. Okay, acha, what are the types of charges? Acha, is this clear now? This is clear, I guess. Electrons, which is negatively charged. This is the okay, leave it, leave it. We'll talk about this. And protons is the positively charged. Neutrons means no charge, zero. Okay. Next one, let us talk about exactly about the electric charge. What is electric charge? Electric charge is the fundamental property of any matter. Okay, which causes it to attract or repel another object. Acha, fundamental property means it is predefined. Okay, upon that one you will create more concepts. Clear? We'll not go into much detail of that how this charge how from where electrons get their charge. Okay, that's the deep science behind it. From at least from here you can understand that electric charge is a fundamental property. Okay, talking about the types of charges, there are two types of charges. First one is the positive charge. Okay, next one is the negative charge. If a body is having no charge, then that is called as the neutral, that we have discussed just now in the last slides. Okay, talking about the symbol, it is denoted by letter Q. SI unit, it is measured in coulomb. Coulomb was a scientist, so in his honor this name SI unit is given. बात करें प्रॉपर्टीज की, सो प्रॉपर्टीज में लाइक चार्जेस मींस इफ इट इज पॉजिटिव पॉजिटिव और नेगेटिव नेगेटिव, दे विल रिपेल ईच अदर, एंड इफ इट इज अनलाइक चार्जेस दे विल अट्रैक्ट ईच अदर. Clear? Clear? अच्छा, बात करें in this figure, that this I have already discussed. If this is a neutral atom and this one is also neutral atom, from one neutral atom if you take one electron and put it into another neutral atom, so now here the number of electrons is more, so this will become negatively charged, and here the number of electrons is less, number of proton is more now, so this become positively charged. Clear, I guess. Again, I'll just quickly wrap it up. Electric charge is a fundamental property. It is denoted by letter Q. It is SI unit is coulomb. Its property is basically, acha, I forgot to tell you this is a scalar quantity. What is a scalar quantity? What is a vector quantity? You will learn better in class 9, 10. Somewhat you will understand. Okay, a scalar quantity means if I say, if I'm measuring the charge, so I can simply say 17 coulomb. Okay, 12 coulomb, and when I have to add this, I can simply add this. 17 plus 12 is a 29 coulomb. I can simply add this. So there is a number, numerical value, there is a unit. Okay, there is no direction. There is no direction. That's why we call it as a scalar quantity. Whenever there is any quantity comes with the direction, then it is called a vector quantity. Well, that's not relevant here. You will learn about that in the higher classes. Clear? Okay, and like charges, as I said, repel each other. Unlike charges, attract each other. Is that clear? Clear, I guess. Okay. Now coming back to the main question of this chapter, what is electricity? What is electricity? Okay, acha, most of you will answer that electricity is something that we get inside our home. Okay, so I'm very sure that you will confuse electricity with the electric current. But believe me, let me check, is the recording okay, fine. So I believe that most of you will confuse electric current with the electricity. Okay, I'm very sure. Electricity is basically the branch of physics where we study about the electric charges. What are the electric charges which can be at rest, which can be in motion? Okay, and the properties associated with it. So electricity is complete branch of physics where we talk about the charges, not changes. Charges can be at rest, charges can be in motion. Achha, when the charges are at rest, it shows some property that we read under the static electricity. Okay, so from here you understand static electricity is a branch of physics where we read about the properties of charge. Don't worry, I'm not writing anything, doesn't mean that you don't get notes. At the end of the lecture, in the description, you will get every notes in the detailed written one. Don't worry. So static electricity is basically the branch of physics in which we study about the electric charge which is at rest and the properties associated with it. What I said? Static electricity is a branch of physics in which we study about the properties associated with charges at rest. Clear? At the same time, talking about the current electricity, so it is opposite. Current electricity is the branch of physics in which we study about the properties associated with charges in motion. Is that clear? So whether it is static electricity or current electricity, it is a branch of electricity. Okay, electricity is overall thing. Okay, acha, now I guess you are getting some of the things. So what is your idea about electricity? That is different. Okay, electricity is a branch of physics. It is a study branch of physics. Okay, what is electric current? That we'll see in the next chapter. Okay, so I hope this is clear. Charges, when it is charges at rest, that comes under static electricity. Charges in motion means the current electricity. Well, in this chapter we will solely focusing on the current electricity. Clear? We'll talk about the current electricity. Clear, I guess. Okay, fine. Now talking about the electric current. Okay, now Electric current is the basically the flow of charges. Let's say there is a conductor. Let's say there is a conductor. Acha, we'll talk about the conductor and insulator also. Don't worry. So let's say there is a conductor. Okay, there is a conductor through which charges are flowing. Charges are flowing. Acha, the more clarity will be in the higher classes, but these charges are nothing but the electrons. What kind of electrons? Free electrons, which are free to move. Okay, more better way I call it as a valence electrons. Acha, this is a little more complex, na? Acha, just keep these words in your mind. It will come again in the senior classes. You will understand what are valence electrons, free electrons, these things. So for now, I can tell you these are the electrons. Acha, in the last slides when I was explaining this one, I told na electron carries some charge on it. Electron carries some charge on it, so that's why the flow of electron I call it as a flow of charges. Same thing, right? Flow of electrons I call it as a flow of charges. Clear? This is clear. Now electric current, if I have to define the electric current, so electric current is basically the rate of flow of charge per unit time. Okay, it is rate of flow of charge per unit time. Okay, which is the form in formula I can show it like this one. This one, I, which is the electric current, Q is the total charge, T is the time taken. Okay, I is measured in ampere. It is measured in ampere. Q is measured in coulomb. T is measured in time. Acha, the SI, talking about the SI unit of electric current, so that is ampere. SI unit is ampere, which is denoted by A. It is Ampere. Ampere. Acha, Ampere was also a scientist. I don't remember his full name as of now, but Ampere was a scientist. So in his honor, this SI unit name was given like this. Okay. So again, I is the electric current, which is measured in ampere. Q is the electric charge, which is measured in coulomb. Time is the T means time, which is measured in second, which is its SI unit. I hope it's clear. So you got the very first formula of this chapter, and in this whole chapter there is only one formula. So you must understand that. Okay. I is equals to Q by T. Achha, when I say that I is equals to Q by T, so this is one formula, but the questions can be asked in different way. Okay, from this formula only, I can derive two more formulas. I can write Q is equals to I times T, or I can write T as equals to Q by I. So all this formula, three formulas are valid, which comes from this main formula only. There's no new formula. Understand? So there's no new formula. Based on that, shall we try one question? I'll take this question there on the next slide so that we can solve it. Okay, let us take this one. Oh, wait. This card, and we'll take 1 second. 1 second. Okay, is that clear? Fine. So let me take that question. Okay, better I take from here. See, it is saying that if a charge, can you see? Can you see? The question is saying if a charge of 12 coulomb, okay, if a charge of 12 coulomb flows through a wire in 6 seconds, what is the electric current? So we are given with every question. We'll try to do like that. What all information are given? So we are given with the total charge of 12 coulomb, and time is given as 6 seconds. What is the electric current? So we know that I is equals to Q by T. Okay, now Q is given, which is 12 coulomb, and time is also given, which is 6 seconds. Achha, everything is given in SI unit, so need not show that. You can just solve it. You get 2, and SI unit of current is ampere. So your answer is 2 ampere. Got it? Got it? Achha, while putting these values, make sure that everything is there in the SI unit, like charges in coulomb, SI unit, time in the coulomb, time in second is the SI unit, and the current will also come in the SI unit. Clear? Acha, if it is clear, let us do one more problem. Let me just frame some question. Let's say I give you, I can take any value. Let's say I'm given with the Q, I have to find out. T, I am given with 7 seconds, and I is equals to uh, 4 ampere. What is the Q? Try to find out. Pause the video, try to find out. Okay, so again, I will use the same formula. It's not any other formula. I is equals to Q by T. Now Q is missing, I and T are given. So Q is equals to I, T. I ka value is 4 times T is 7. So 28. What is the SI unit now? 28 coulomb. So that's how you can find out. Achha. In next question, I can remove the T also, and again, I can give you some values. Okay, let's say I give you Q as 40 or 70, 75, let's say 75 coulomb. I give the charge as 75 coulomb. Okay, and I, let's say I give as 15. Q I'm giving is 75 coulomb. I'm giving as 15 ampere. Okay, and you have to find out the time taken. So again, you will apply the same formula. I is equals to Q by T. I can write this as T is equals to Q by I, which is equals to Q is 75 divided by I is 15. So your answer is 5 seconds. Clear? Clear, I guess. Acha, let us take some some more problem where you'll have to change the SI unit. Okay, now you will try to do this question again. Let's say I take Q ka value as 4 coulomb, okay, and time I take as 2 minutes, okay, and you have to find out what is the electric current. I is equals to Q by T. No, better I give you Q. If I give you Q is equals to IT, Q by T. Acha, I have to change this one. 240 coulomb. Okay, I'm changing the value so that it becomes easy for you to solve. So Q I'm taking as 240 coulomb, time I'm taking as 2 minutes. What is the current? Try to do it. Try to do it. The same formula I is equals to Q by T. Apply that formula. Put the values. Okay, put the values, and you will get your answer. Simply I is equals to Q by T. Q is given, T is given, I you have to find out. So what I do? I is equals to Q by T, and my Q is given as 240 and time is given as 2. I cancel out. 2 ones are 2, 2 to the 4, 120 ampere. Correct? Wrong. Why? Why it is wrong? Because we have not kept it in SI unit. See here, time is given in minute, so you have to change it. It is 120 second. Second is the SI unit of time. Okay, so you'll have to put everything in SI unit. Okay, now Q I'm having 240 coulomb and time I'm having as 120 seconds. So when I cancel out, I get 2 ampere. That is my answer. Okay, I hope it's clear. If it is clear, now we are moving to the next section where we will be talking about the conductors and insulators. Acha, in the last slide, we were talking about the flow of electric charge. Okay, now tell me, will this electric charge or the electric current will flow through any object? Will it flow through any object? If not, then how do we categorize those objects? So that here is the categorization, which is the conductors and insulators. Okay, so you see all the objects around yourself, okay, and try to categorize them such that which one will allow the electric current to pass through it, which one will not allow the current to pass through it. So based on that, I categorize all the materials around us in the two categories, which are the conductors and insulators. When you go in the higher classes, there are some more categories. We are not going into detail of that one. Okay, so that is a conductor and insulator. So what are conductors? As the name suggests, conductors are the materials that allow the electric charges to flow through them easily. Okay, whereas in insulator, they do not allow the electric current to pass through them. For example, in the conductor, it can be copper, silver, aluminium. Some more examples are gold, are there, iron are there. So many things are there. Okay, example of insulators are plastic, rubber, wood, glass, and so on. Okay, acha, our body is a conductor or insulator? Our body is a conductor of conductor or insulator. It is a conductor. Our body is a conductor. That's why we should avoid touching the electrical appliances with our hands directly. Okay, so if you get in contact with the electric wires, by mistake, it will, it may cause the big harm to your body. Okay, so that's why we should avoid touching the wires. Okay, electrical appliances, you should be very careful whilst dealing with it. Okay, that's why whenever we are doing in the labs, we prefer to use the batteries, because batteries does not have that much electric current, so it cannot give you the shock that may kill you. But when you are dealing with the directly with the electric current which is coming in your home, so that is very dangerous. Okay, so be careful. Now going to the next slide, what are the sources of this electricity? Sources kahan se aayenge? If you, let's say, the bulb is glowing, so if you can see there is a battery here. Okay, if you remove the battery, how the bulb will glow? Even though free electrons are there in the wire, but can that electrons glow this bulb? Let's say I remove this battery from here and you connected the wire directly. Will it glow? Will it glow? No, it will not glow. So you need some sources of electricity. So overall, we are having two main source of electricity. One is the small scale and one on the large scale. On the large scale, again, you are having lot of options like hydropower plant, coal power plants, nuclear power plants are there. Okay, tidal power plants. There's a lot of plants where electricity on a larger scale is generated. स्मॉल स्केल वी हैव द पोर्टेबल एनर्जी लाइक द सेल्स और द बैटरीज। अच्छा, बात करें अगर बैटरीज की, सो बैटरीज हैव टू टर्मिनल्स, वन इज पॉजिटिव टर्मिनल एंड अनदर इज द नेगेटिव टर्मिनल, that is basically the cell. अच्छा, next section let us talk about the cells and the batteries. अच्छा, बात करें अगर cells की, so cells are the basically they convert the chemical energy into electrical energy, chemical energy into electrical energy. अच्छा, how that chemical energy is converted to electrical energy, that is a different thing. Okay, that you will have to understand, you know, go to more basics into the chemistry. There's some electrolyte inside it, one some reaction happens, because of that the electrons start moving. When the electrons start moving, electricity is generated, electric current is generated. Okay, so that's how it is generated. Clear? Okay. Now, talking about the electric cell. So, if you have to define, electric cell is nothing but it is an electrical device which converts chemical energy to electrical energy. Talking about the batteries. Okay, batteries are the combination of cells. Okay, like this one cell, this is positive, negative. You attach like this one. That is another cell. You attach like this one. This is positive, negative. You attach like this one. This is positive and negative. So what you observe here, you have to connect in series. This is called as a series combination. You have to connect plus with minus, then plus, then minus, then plus, then minus. In that order, you have to connect the cells in order to get the batteries. So batteries is what? Batteries are basically the combination of cells. If you see here, this torch will not glow because positive is connected to positive and negatives are opposite. So this bulb will not glow. What you have to do, you have to connect in the opposite order. Okay, positive terminal of the battery must be connected. Positive terminal of the cell must be connected to the negative terminal of another cell. That's how you get the battery. Okay, if you see a cell, so on the upper side, metal cap is generally positive, and lower side, which is the disk side, is the negative terminal. Clear? This is clear. What is a cell and how do you make the batteries? So that's it. Acha, talking about the types of batteries. So generally, what are the types of the batteries? You know, broadly, it is classified as primary cells and the secondary cells. Talking about the primary cells, in general, you can say broadly, the cells which cannot be recharged again. The cells which cannot be recharged again, like these batteries you might have used in your, cars or the wall clock. These batteries you might have seen. You cannot recharge it again. That's why it is called as the primary cell, single use cell. That's why it is also called as a single use cell. They cannot be recharged. All the batteries that we can recharge, like the battery of your laptop, like the battery of your phone, like the battery of your smart watch, okay, battery of your Bluetooth. So these batteries can be recharged again. That's why these are called as the secondary batteries. Talking about some of the examples, so voltaic cell is there, Daniel cell is there, Lagrange cell is there, dry cell is there. You don't have to go into detail of that, what a dry cell, Lagrange cell, and all those things. That will come in the class 8. Okay. For now, you have to just remember this the names: voltaic cell, Daniel cells, Lagrange cell, and the dry cells. Okay. Talking about the secondary cells, like secondary cells are really useful in our day-to-day life today. Okay, it can have addition cells, lead acid cells, accumulator. Nowadays, in the cars also, the batteries are being used. That's called the lithium-ion batteries. Lithium ion batteries, which are used in the cars nowadays. So this one, I guess I told already. Electric cell basically stores the chemical energy. Some chemical reaction happens inside, and that converts to the electrical energy. Clear? Clear? I guess we can go to the next slide. Okay. Except those primary and the secondary cell, there are some more categorization of the cells, which are the button cell and the solar cell. What is the difference between a button cell and the solar cell? Button cell is basically its composition means it converts the chemical energy to electrical energy. Button cells are basically smaller in size. That's why it is used in your Bluetooth. It is used in the smaller mics. Okay. It is used inside your watch. It may be used inside your calculators. It can be used. Talking about the solar cell, it does not store something. It takes the sunlight and converts it into electrical energy. There's nothing stored prior. It just converts solar energy into electrical energy. That's why it is a renewable source of energy. Okay, renewable source of energy. Now, talking about its applications, so you can see on the street light, on the homes, we use the solar panels, and most importantly, it is used in the satellites. Because in the sky, you don't have electric current. You cannot carry the batteries. You cannot carry the generator to generate the electricity. So we take the electricity to the satellites using the solar panels. Okay, clear? Now, next one, talking about the bulb. Okay, bulb versus the LCD, LEDs. Okay, so first one is the incandescent lamp, and next one is the LED, light emitting diode. क्या डिफरेंस है इन दोनों के बीच में? पहले बात कर लेते हैं incandescent लैम्प के बारे में. तो इसमें दो टर्मिनल होता है. इन द फर्स्ट टर्मिनल एनीथिंग कैन बी पॉजिटिव और नेगेटिव टर्मिनल. उसके बीच में ये जो है, ये एक फिलामेंट होता है. फिलामेंट इज मोस्टली मेड अप ऑफ द टंगस्टन वायर. ओके, या निक्रोम का होता है. निक्रोम का क्यों ऐसा होता है? बिकॉज इट हैज हाई मेल्टिंग पॉइंट. इट हैज हाई मेल्टिंग पॉइंट. सो ये जल्दी से मेल्ट नहीं होता है. अगर ये फिलामेंट टूट गया, if this filament is broken, the bulb is gone, you cannot use it anymore. Okay, so generally this kind of bulb consumes a lot of energy. Okay, so to glow this bulb you need a lot of energy. Okay, so outer layer is the glass, this is vacuum packed, and inside that some gases are filled. That gases are the inert gases. What are that inert gases? Nothing to worry about that. Just understand as of now, these are the inert gases, like the neon are there, xenon are there. These are some of the names. If you can remember, that's fine. If not, then no problem. In the further classes, it will come again. Okay, so basically there are two terminals which go, and there is a filament in between, and this bulb is seal packed, not vacuum packed, seal packed, filled with these gases, neon and xenon. Acha, the drawback of using these bulbs is that you have to apply a lot of electrical energy to make this bulb glow. Okay, to make these bulbs glow, you'll have to apply a lot of electrical energy. Okay, if the electrical energy is not enough, it will not glow. Okay, basically, it what happens when it connected and the electricity goes to the filament actually produces the heating effect. Because of heating effect, it starts glowing. Okay, that's the main basic working of that. Talking about LED, actually in LEDs what happens, there are different cells of electrons. So electron jump from one cell to another cell, but it has a tendency to come back. Okay, so when it comes back, it releases the energy in the form of light. Acha, if you don't understand this one, no problem. That is a higher level of little chemistry. That the working of this bulb is not because of heating effect. Okay, it is not the heating effect. It is because of the transition of electrons between different cells. That's why it is called as the runs cooler. It does not generate heat, and because of that, it can work on the shorter, less energy also. In the less energy also, it will work. Like this bulbs, you can use connect with battery, different cells, and it will glow. But if you connect this one with the cells or the battery, it will not glow because it requires high amount of electric current. Clear. In this one, if you see a LED bulb, the longer wire shows the positive terminal and the shorter wire shows the negative terminal. Again, I'm saying that I'm not writing a lot of definition or something here. I will be attaching the notes or detailed notes in the description, so not at all worry about that. Clear. So I hope you are clear with this incandescent lamp and LED, which is light emitting diode. Main difference between them is that incandescent lamp uses a lot of energy, and it works on the heating effect of electric current, the basic principle of working. Talking about the LEDs, so these are the runs cooler. It's not because of the heating effect, it's because of the transition of electrons between different cells. Clear, I guess. Clear. Okay, now next one, talking about the electric circuit. Just give me a second. Okay, talking about the electric circuit. So electric circuit is basically a complete unbroken path for electric current to flow. Okay, like this one. If you see a battery is connected, a wire is there, if it's connected to the bulb and it is here, but here it is open. So this circuit is called as the open circuit. Okay, if it is open, it will not glow. Although it is shown here, it will glow, but no, it will not glow. What you will have to do, you will have to connect this one. The switch must be closed. Then the circuit is complete. The electron starts moving, and the circuit is complete. Then you can say that the bulb will glow. Okay, so it is basically the unbroken, complete path of electric current to flow. Okay, in that one, there's a different components like the connecting wires are there, switch is there, bulb is there, cell is there. Okay, and batteries are there. For your syllabus, this much is enough. When you'll go in higher classes, there's some more. There's a lot of electrical devices are there, and their symbols are there that you will read in the further classes. For now, this much is enough. Acha, whenever I'm gonna draw, so it's not like every time I will draw like this one. We are not gonna draw like this one. So I can in short, what I can draw. See here, I can draw like this one. This is positive terminal. This is negative terminal. This is the wire. Here is the switch. I can put a bulb here, and this is what? This is called as the circuit diagram. This is called as a circuit diagram. Okay, so what we do, we don't actually draw the figures like bulb and batteries every time, because it is really hectic. So to show that, we use the electric symbols. Like for the wire, this is the symbol. Switch, which is open, is like this one. Bulb like this one. Cell is like this one. Batteries are like this one. I'll show you the batteries also, like this one. More number of cells you will connect. This is negative terminal, this is positive terminal. The longer wire will be positive, shorter wire will be negative. So this is for the battery. This is the closed path. This is the it came here, battery. This is negative terminal, this is positive terminal, and this is the switch, closed switch. Clear. This is very helpful for the engineers to create the blueprint of any circuit. Now you are having the very simple circuits. When you go in the higher classes, there are complex circuits, so that every time you cannot draw the figures of battery, cell, bulb, everything. So that's why we use these symbols. Okay, also it is a universal symbol. It is used by everyone. Clear. So this one about the switch, I discussed already, I guess. When the switch is in on position, So the circuit is closed and the electrons flow easily. Okay, when the switch is off, the circuit is broken and the bulb does not glow. Okay, so the main work of the switch, it is a device which is used to complete or break the electric circuit. Clear? A device which is used to complete or break an electric circuit. Clear? Clear till here, I guess. Okay, now next one is our electric tester. How do you test whether an object is a conductor or insulator? Okay, now this one is a kind of a small activity or kind of a small projects that you can do in your school project to check different materials whether they are conductor or they are insulators. Fine. So what you do for that, you make the circuit like this one. You take a battery, you connect it to the wire. Here is a bulb, and you leave a space here. This point is called as the tester. What we will do, we will put the objects here. Let's say I put the metal. Let's say I put a metal here. Okay, so that time the circuit is closed and my bulb starts glowing. Let's say I put a rubber here. Okay, so rubber is an insulator. So when the rubber was kept, the circuit is not complete and the bulb does not glow. So by keeping different things here on the tester, I can understand what are the conductors, what are the insulators. Clear? So, acha, this is the normal working of a tester. Okay, tester to understand whether an object is a conductor or insulator. Acha, what if you are putting a conductor here? Let's say you kept the conductor here, still the bulb is not glowing. Okay, so there is some problem in the tester. So that we will understand, that we will try to check whether my tester is working properly or not. Okay, before using the tester, we should ensure that it is working properly. Clear? So first we will check whether any wire is broken or not. Okay, if the wire is properly fine. So if the wire is completed, the bulb must glow. If the bulb does not glow, then you have to check upon three things. Okay, whether you check the battery source, the cell what you're providing, is it depleted, like is it having power to glow the bulb? If not, then you change this one. Okay, next one, what you check the filament of the bulb. If the filament is broken, the bulb will not glow. That time your tester is of no use. Okay, next you check your wiring. Is there wiring broken somewhere? Is your circuit complete? If it is not complete, then in that case also the tester does not work. So what you have to check? You have to check on 3 points. You have to check on battery, you have to check on the electric bulb, you have to check on the wires. Achha. If you do that one, it may happen that still it does not work. Still it does not work. Then in that case, what you will do? Still you may feel like, let's say you kept a let's say a metal spoon there. Still the bulb is not glowing. That may happen because you are using a incandescent bulb. Okay, what I told when I was teaching in this slide, let's say this one. So what I told, this bulb require more amount of energy to glow and this bulb require the less amount of energy. So what I do in my tester, I interchange the incandescent bulb with the LED bulb because LED bulb require the less amount of energy. So let's say some less amount of electric current is passing through this one. So even by the less amount of electric current, the LED bulbs will glow. But at the same time, if I put the incandescent bulb, so that may not glow because it requires more amount of electric current to glow. Clear? Clear, I guess. So this is the modified LED tester which can work on the smaller current also. Now we are on the last part of this chapter where we'll be talking about the torches. अच्छा, torches में simple है. If you take a cover, ऐसे इसका एक outer layering बनाओ. Okay, and इधर से तुम you put the cells. Okay, and 2 cells. I may draw the 3 cells. Okay, तुम यहाँ से क्या करो, एक वायरिंग यहाँ से लो, ये स्विच के पास ले आओ, एक वायरिंग जो है यहाँ से ले जाओ. ठीक है, वेट इसको जो है जाके ये बल्ब में लगाओ. लेट्स से कि देयर इज अ बल्ब हियर. आई एम ड्राइंग रफली कि हम क्या करने वाले हैं. इसको फिर यहाँ से ले जाओ और यहाँ पे एक तुम स्विच लगा दो. ठीक है, व्हेन वी स्विच इट ऑन, द सर्किट इज कंप्लीट, द बल्ब विल ग्लो. तुम स्विच को तुम कट कर देते हो, द सर्किट इज इनकम्प्लीट, सर्किट इज ब्रोक एंड द bulb will not glow. As you can see here, जैसे कि यहाँ पे बल्ब लगा हुआ, सेल्स लगा हुआ है. सेल्स इन द सीरीज कॉम्बिनेशन, हमेशा याद रखना कि इट मस्ट बी अटैच्ड इन द सीरीज कॉम्बिनेशन. ठीक है, cells connected in the series combination gives you the battery. So वहां से अगर बैटरी वहां से connected है, it is connected like this one and it is glowing. Clear? So from here you get a light source. Clear? यहाँ से light source आ गया. फाइन आई गेस. अगर और ये रेगुलेट कहां से हो रहा है? स्विच से. स्विच यहाँ पे जैसे ही क्लोज हुआ, ये दोनों वायर एक दूसरे से कनेक्ट हुआ, बल्ब इज ग्लोइंग. व्हेन द स्विच इज ऑफ, ये यहाँ से सर्किट जो है ब्रेक हुआ एंड द बल्ब डज नॉट ग्लो. ठीक है, क्लियर हुआ? तो इसमें क्या क्या कंपोनेंट्स है? इलेक्ट्रिक सेल्स हम यूज कर रहे हैं, स्ट्रक्चर हाउसिंग एंड कंडक्शन पाथ है, लाइट आउटपुट. सिंपल सा अंडरस्टैंडिंग है. क्लियर आई गेस. अच्छा, लेट्स कम बैक टू दिस आर द समरी पॉइंट्स. व्हाट इज द इलेक्ट्रिक करंट्स, जो हम अभी तक डिस्कस कर चुके हैं ऑलरेडी. इलेक्ट्रिक करंट इज द कंटीन्यूअस फ्लो ऑफ चार्जेस पर यूनिट टाइम, जिसका कि फॉर्मूला Q/T होता है, यूनिट SI यूनिट एम्पियर होता है. बैटरी क्या होता है? कॉम्बिनेशन ऑफ सेल्स. सेल्स क्या होता है? सेल्स एक इलेक्ट्रिकल डिवाइस जो स्टोर करे रखता है chemical energy को, and it converts the chemical energy into the electrical energy. Clear? Talking about the circuit. So circuit is basically the complete unbroken path for electricity to flow. Switch क्या होता है? किसी भी डिवाइस को स्विच ऑन और ऑफ करने के, सर्किट को बेसिकली ब्रेक करने के लिए और कनेक्ट करने के लिए स्विच को यूज करते हैं. कंडक्टर्स, एनी मटेरियल्स दैट अलाउ द इलेक्ट्रिक करंट टू पास थ्रू इट इजीली, लाइक कॉपर हो गया, सिल्वर हो गया, एल्यूमिनियम हो गया, आयरन हो गया, गोल्ड हो गया. इंसुलेटर्स क्या है? विच डू नॉट अलाउ इट, जो ब्लॉक करता है इलेक्ट्रिक करंट, द फ्लो ऑफ इलेक्ट्रिक करंट, लाइक रबर हो गया, प्लास्टिक हो गया, वुड हो गया, पीवीसी हो गया. दिस अ लॉट मोर एग्जांपल्स. क्लियर? अच्छा, let's have a quick quiz. What is the SI unit of electric charge? Coulomb. What is the specific part of incandescent bulb gets hot and produces light? That is a filament. True or false? In a battery, the positive terminal of one cell should connect to the positive terminal of the next battery? No. होता क्या है? पॉजिटिव को नेगेटिव से जोड़ते हैं, नेगेटिव को फिर से पॉजिटिव, पॉजिटिव को नेगेटिव, नेगेटिव से पॉजिटिव, एंड सो ऑन. वी डू इट लाइक दैट. क्लियर हुआ? एंड यस, डन. So that's the end of the chapter. We completed this chapter also. Electric current. We discussed about the we started with this one. If you want, I can get you back there. Okay. So we basically completed this chapter, which is the circuits and their components. I hope everything is clear. Okay. अगर कोई doubt है, you go back to video again, try to see it again. उसके बाद भी अगर doubt है, you put it in the you can put it in the comment section. I'll try my best to give you the answer reply for that one. Okay. कोई भी concept कुछ भी अगर नहीं समझ में आ रहा है तो try to do it. अच्छा, best thing, don't just rely on this lecture. मैं बार बार बोल रहा हूँ. You will be having your textbook will be there. NCERT textbook है या जो भी textbook है, you try to read it out once. ठीक है, खुद से एक बार पढ़ो. ठीक है, try to read by yourself, mark it, and then you get the best understanding. अच्छा, talking about the notes, मैं फिर से बता दे रहा हूँ कि in the description I'll be adding the link for the notes. Complete the notes in the text form, so you will get that text notes. So there's nothing to worry about that. Okay, so that's it for today. In the next class we'll be starting the next chapter. Okay, thank you.